Two off my head.
Where's that? Yeah, these ones, after the 180, they get it back on the side, which one?
Still out there.
You still. One and a half. So that's all, that's all. That's like 2 days, all we retract, and you're going to understand. Oh, it is.
Well,
Especially not over there. Maybe. Okay, so something is the Frank Farm, that was this week.
Check the contract.
so that gives. Yeah. Thanks.
Okay, I think you're gonna find these two sections pretty straightforward because you're just taking the information that we've already learned and putting it into these formulas. So if you look on the back of your calendar, you're gonna see these formulas that we're really just kind of working towards. It's the bottom third of the page. We have multiplication by complex numbers, multiplication of complex numbers. We have division of complex numbers, and we're just basically putting this into the form because we know how to get from rectangular to polar, from polar to rectangular. If we have our radius and theta, we can just insert into this formula and get the form that we want. So if we're doing multiplication, we're going to be multiplying the radius and then adding the thetas. If we're doing dividing of complex numbers, we're going to divide the radius and subtract the thetas. We'll refer to these formulas and just plug them in because the hardest part is just getting from one form to the next. But once you do that, we can just put things in. Yesterday, I know I said that the test was calculator, but looking back last year, I realized that the test for this unit is non-calculator. Okay, so we'll work from that perspective. You can obviously use your calculator during class, but we're going to show the process of practice the process of getting to our answer without calculators. Okay, so I'm not going to spend the time to derive this formula. We're just going to write out the formula. And so if I have two complex numbers in this form, if I want to multiply them together, basically I'm just going to multiply the radius and add the thetas together. So we're going to take our information and basically just put it into this form. So we'll take the two radius from the two complex numbers, multiply them together. We'll take the two thetas, two different thetas from the two complex numbers, and we're going to add them within the sign within the cosine.
What is this? Do I have to go?
During third period, so I mean, we'll be done with the notes in like 15 minutes. Let's go for that. Okay, so I put the formula above. We're just going to apply this formula here. All right, so it says find the product of the complex numbers in polar form. So the nice thing with number one is everything is given to us in polar form. We're just going to multiply using the process above, and then to get it into rectangular form, we'll just distribute the r through and then resolve the cosine and sine and get it to be a plus bi. All right, so what is my R1 and R2 for these two complex numbers? 4 and 3, yep. So take 4 and 3, multiply them together. Yeah, you can just go ahead and put 12 if you like. I'm just going ahead and just put everything down so they can see where it's coming from. All right, and what are my theta 1 and theta 2s?
225 and number.
Yeah, so I'm just going to take those 2 degree measures and put it into my formula. All right, any questions so far? All right, so 225 plus 90 gives me 315. So this is polar form for my answer. Then to get to rectangular form, we're just going to distribute the 12 through, and then eventually we'll end up with a plus bi. Let's practice using this without a calculator. You guys created a unit circle from yesterday, so why don't you use that, refer to that as you build out your rectangular form.
The test is not calculated.
Non-calculator for the test, yeah. So you'll get a blank unit circle, but for now, you can just refer to unit circle as if you already created it.
You just leave it at that, just keep going.
So this is our answer for polar form. Not if it's in polar form. It says answer in both in polar form and rectangular form. So if we distribute the 12 through and resolve for cosine and sine, then that's a process converting from polar to rectangular. So this is part A of our answer. Part B of our answer is where we distribute that through. All right, so look on your unit circle. Cosine of 315, what's that going to be? √2/2. And then sine of 315, -√2/2. Yeah. So once you get your answers, know that there's 2 forms, right? They both are the same answers. There's just different form, right? Your polar form has r and theta. Your rectangular form has horizontal and vertical, x and y component. Any questions? For number 2, we're going to make the adjustments of dealing in terms of radians. So let's just practice using radians, even though technically you could convert it to degrees, but let's just for practice purposes, let's go through radians. Yeah.
Do you have a circle thing?
Oh, yeah. Yeah, I forgot what it's called. Unit circle.
I mean, a circle. Like. is- Like,
Okay, so let's go ahead and try number 2. You guys have the formula. I'll just work alongside you guys as you guys try number 2 as well. So I took advantage of the fact that I can save a step. So I replaced 2, 5, or 3 as 4, 5, or 6, so I can get the common denominator to make it easier for me to add them together. Okay, so it's not hard, right? Just have to kind of make sure we are comfortable with unit circle values again. Yeah.
Why would it be 6? Root 6 instead of 5? Like I thought you like added
Yeah, I am.
or
Oh, add,
you still multiply it.
multiply, yeah. It's root 2 over 1 times 1/5, so root 2 times 1 is just root 2, 1 times 5 is fine.
But like if you're doing root 2 times root 3,
Uh-huh,
you still multiply it.
you still multiply it, yeah. Now, yeah,
That's Jamie.
Mhm.
We have to memorize this formula for the quiz tests.
let me get back to you. For now, I'm gonna say yes, but let me get back to you tomorrow. Okay. Okay. Any questions? First page. So let's go to page 21. Now, if we're dividing complex numbers in polar form, then we're gonna be dividing the radius and subtracting the theta. Okay, so just know that your first operation will be exactly what you would expect, but then your second operation is gonna be changing. So just associate multiplication with addition and then division with subtraction. All right, does anybody still need this page? All right, so let's go to page 21. So if I'm dividing two complex numbers, then I'm going to divide the radius and subtract the thetas. I'll put this down here so I can write it in place. And notice we're still adding the cosine and sine. We're just changing what's inside the parentheses. Okay. So let's try examples 3 and 4. Okay, 210 minus 60 is 150. resolve cosine and sine, distribute the 1/4, and that then you can convert your polar form to rectangular form. We know that 150 is in that pi over or that 30-degree reference angle. Yes.
Wouldn't the answer in polar form just be like 1/4 plus 150i? Like a plus bi?
Well, that's rectangular form. So yesterday we learned that polar form has r and theta in it.
Okay, so what did it, also rectangular form, like a plus bi only has to do with like x and y now. You can't plug in like the radius.
Well, if we were to distribute everything through, because we know that x is r cosine theta and y is r sine theta. Right, so if I were to resolve the theta and the r and clean all that up, then it turns into a rectangular form. Yeah, think of rectangular form as your x and y values, and then your polar form has radius and theta.
It's like a and b is like x.
Exactly, a and b is your x and y. Right, so cosine of 150, that's going to be negative √3 over 2. And sine of 150 is 1/2. Yeah, you can also see this spelled out nicely on your summary form as well. Rectangular form is a plus bi. Polar form is r cosine theta plus I sine theta. All right, number 4, same idea. It's just that now we're having to deal in terms of radians. Mhm.
Because that would be negative, do we have to add,
Yeah, so if you don't recognize negative radians or negative degrees, you can always add 2 pi or 360 to get into something that you recognize. But you don't have to, but I think a lot of students prefer to add 360 or 2 pi to get it more familiar. Okay, 2/5 divided by 1/2, the same thing as 2/5 times 2/1 times the reciprocal. Okay, if you don't recognize negative pi over 4, you can rewrite it as 7 pi over 4 because you can always create a coterminal angle that fits into your 0 to 2 pi range. Add 2 pi minus pi over 4, or 8 pi over 4 minus pi over 4, 7 pi over 4. It's in the fourth quadrant. You can leave your answer in either form. These are both legitimate polar form.
I did like two pi minus pi over four, pi over four minus pi over four, and I got, negative three pi over four.
Oh, my bad, I messed up. 2 pi, yeah, my bad, negative 3 pi over 4. Sorry, I added it wrong. 2 pi minus 5 pi is negative 3. Negative 3 plus 8 pi over 4, what you get? 5 pi, yeah. That's right, both would be legitimate, yeah. You know, it does feel nicer with this one. This leads into the next step better, but because you know 5 pi over 4 make it a little bit more familiar than with negative 3 pi over 4. So this step kind of gets you ready to get into the next one, because you can recognize that rectangular form a little easier. But both are legitimate polar forms. So now let's move into rectangular form. This is in the pi over 4 family. We know that cosine and sine will be root 2 over 2, but this is third quadrant, so they'll both be negative. Okay, any questions? All right, your classwork will be on page 22 to 23. Let's just do the evens, okay? So 2, 4, 6, 8, 10. Evens. I'll put the answers up after a few minutes for 2 and 4.
Zero side canceling. Zero side canceling.
Yeah, 0 times I will just 0 out. Yeah, the I will just completely go away once you get to the rectangular form. Yeah, it's going to happen for both 2 and 4.
So if it is a 100, does that mean, is it still rectangular? This triangle?
Yeah, it's -10 plus 0 I, so it's thinking as -10, 0.
So
But you can leave the I out just because it goes away, but you can, if you want to make it A plus BI so that it's clear in your head, you can more than welcome to say -10 plus 0 I. We're okay with 2 and 4? Yeah, so, I'm sorry, that should be, dividing. So dividing, I gotta, divide the 4 and 2 and then subtract the radians. So it's a division sign. Do you see that? Okay. So we have to subtract. So I just found common denominators, 9/4 minus 3/2, same thing as 9/4 minus 6/4.
Where'd you get this? Oh. Okay.
Just matching common denominator. Never tangent the same, they're the same. That's the same thing as moving that tangent over and saying, when is tangent and data? Yeah, and that's the sign of the project, that's gonna be part of it. You know that.
Right.
Right, here's number 8 and 10.
Yeah, I just completely forgot that they all want to find something. Thanks.
So,
You guys give it a few minutes and I'll let you guys get your phone. I want to see, make sure everyone has a chance to finish off first.
Well, it's still there. I'm sorry. I keep my streets, but I saw that my eyes were. So. That's. What do you do? Okay, sitting with fun, interest. I don't know. I don't know. Like it's like. I don't want to just keep that. I got 80. I got that. Every single street. I've got an 80. I get that. Oh my, I have to look at the effort kids added to it. Well, I did the math, but I got one of the upper cube. So if that's the case, then I got a. I got equal, right? Yeah. That's why I got. So if I got 4 out of 5 in the end. I don't know what it's 80. I know. I got 80. I got 80. I didn't know why I did this. Wow, really? 80? Now 80. Yeah. No way. But. Yes, I think I even ended up taking it.